All right, everybody, we're going to get started. Thank you so much for joining us today for this 1-hour webinar titled Efficient FTTH, Fiber to the Home Termination. My name is Ashley Skitt. I'm the Director of Marketing here at Tempo, and I'm going to be the moderator for today's course. So a few things, you're all on mute, and you're going to remain muted throughout the duration of the presentation. But if you have a question or a comment, please put it in the chat box. And to find that, you can open the chat box by clicking the conversation bubble icon at the top of your screen. And questions will be answered at the end of the presentation. So we'll take them all for the end. Now I'd like to introduce you to your presenter, Keith Ford. Keith is the Fiber Optic Product Manager at Tempo Communications. He has over 35 years of experience in the design and development of OTDRs, OLTSs, and other fiber optic test equipment. He's a seasoned presenter within the telecommunications industry on a wide range of fiber optic topics. So Keith, the stage is yours.
Excellent. Thank you, Ashley, and thank you everyone for being here today. We're going to talk about, the last mile termination, the one that's in your house, basically. And a lot of people, they don't give it the justice that is needed, really, and they kind of give it short shrift, and they don't pay too much attention. They hope that everything will be okay. Well, that's not really a good plan, and because you have to rely on the entire network working, and the weakest link could bring it down. So you have to give the last connection a lot of consideration. So when you're doing a termination in fiber to home, and it doesn't matter if it's really the last one at the ONT or the demarcation point, it could be anywhere, every fiber connection. But specifically with fiber to the home, you're looking for a low-cost solution that's easy and fast to terminate, and at the same time, you're looking for the lowest insertion loss and low reflectivity, because reflections are the enemy of your network. If you start introducing reflections, you're going to cause a lot of trouble. And on top of that, you want a reliable connection, and you want long-term performance. But you don't want to pay so much, right? But it's kind of at odds, these kinds of situations, these requirements. And so what we're going to talk about is a couple of different methods of doing that final termination. And so we'll get started with mechanical connectors. Mechanical connectors, you can see on the picture on the right-hand side there, there's two of them. One is SC-APC, that's the green one, and SC-UPC, which is the blue one. And so the SC-APC will give you a lower reflectivity. That's going to be at least minus 55 dB down, and that's a mated connection. The UPC, which is more used in the premise type of applications rather than fiber to the home, has a little bit higher reflectivity because it's a flat polish, not the angle polish. But these both will give you very fast economical termination, and you can install them probably in less than a minute if you've gained a lot of practice with them, and you know the method you understand the methods, and you're able to refine that and get down to less than a minute. That's for sure. You can use these on 3 millimeter, 2 millimeter, 900 micron, and 250 micron type cables. Now, if you're not happy with the connection that you made, you can take it out and put it back and try it again, re-terminate. You're going to re-cleave it and all that, and you can have 5 attempts at it. And so you're not wasting connectors, okay? And the real big advantage of the Tempo Communications mechanical connector is that it is GR326 compliant. And that's a Telcordia specification, which gives you the assurance that you're installing a quality connector, a connector that is not going to cause trouble, that's going to be meeting the specifications that is outlined under very rigorous testing conditions. And so we're going to talk a lot about that also. Now, here's a typical use case, and this is on the outside of someone's house, and you can see there's a drop cable comes down, and that there is terminated, and then there's a pre-terminated cable that takes it into the house. Now, that pre-terminated cable, it might not be used necessarily. Sometimes you have another cable that you have to terminate at the ONT inside the house, But because if you have pre-terminated cables, you got a lot of slack and issues. You have to store it somewhere. But this is typically where you would be using a mechanical connector to at the ONT. So at Tempo Communications, we're really stressing the educational aspects and helping the technician and the customers understand how to best use the product. And so this here is I lifted it straight from the instruction sheet, and it tells you exactly how to do the termination step by step. And you'll notice that there's some stripping tools, a Kevlar shear, and a cleaver, and that's it. No other tools are required. You don't have to have an expensive fusion splicer and all that, but these are the tools that will get you up and running so you can do a termination. Now, as long as you follow the instructions properly, everything will be okay. And like I was saying, we're about helping out with education and whatnot. We have application engineers who you can call up, and if you have trouble, you can give them a call and see if they'll be able to help you get over some hurdles that you may have. And there's online videos and that, so we can show you how to do the termination, because we want you to be successful and have good terminations and not have trouble and not have callbacks, re-rolling trucks and all that business. We want you to buy more connectors, and so we're there to help you be successful. And so the instruction sheets are very clear, and you can download these from the website or whatever, and they're included with every 10-pack of connectors. So getting back to GR326, that's the Telcordia specification, and basically we sent them out to an independent third-party lab to be tortured. What they did was they took 30 connectors and they put it through temperature cycling and humidity and all this kind of stuff, and they're like measuring the insertion loss and the return loss and the performance to make sure that the specifications for the mechanical connectors are being met. Okay, and they did this 21 cycles over 7 days. They do this with all these measurements that I'm going to show you. And basically, they're taking a cable, to terminate a cable with the mechanical connector, they're twisting it and they're pulling it and they're bending it and doing all kinds of crazy things, trying to make it fail. And they're doing this while they're monitoring the insertion loss and the return loss. And so when it passes this very rigorous testing, you have assurances that yes, indeed, the connector is meeting the specifications and that is a quality product. One of the major considerations is the end face geometry. And we have a electro-optical mechanical engineer on staff in Vista, and he was able to take the initial design connectors and validate the end face geometry. And the end face geometry is so important because it guarantees that the losses and the connectivity and the compatibility between other manufacturers connectors is going to meet those same specs, as long as those other connectors are still GR326 compliant or very, very high quality connector. And you can see there's many mathematical exercises on the right hand side of this. And so we're looking at the apex offset. How close is it? How close is the fiber to the center of the connector? The dome, is the dome consistent shape? The radius and all these different measurements of the fiber end face, the ferrule end face, are measured, and during the manufacturing process, they're carefully monitored, because you have to keep within those very, very micron measurement type of specifications to meet these performance goals. And so, with our mechanical connectors, you have the assurance that they're able to meet these specifications when mated with other connectors. And so I'm not going to drag you through all that mathematical mumble jumble there, but you have assurances that we've checked this out And that third-party lab that I spoke of, they also checked it out. Oops, went too far. So there was a lot of mechanical tests also. They've put it on vibration tables, they do flexing and twisting, and they hang something like 15-pound weights off of them. And they're constantly measuring the insertion loss and return loss when they do this. And this is over the course of many, many days. Okay, this is why it takes about 2 to 3 months to complete this testing. And all of this is listed in the GR326 document that you can buy online. You know, it's about $895, I think, or something. And one of the tests that you can see there on the right-hand side, that there, they take it to a horizontal position and they drop it so the connector hits that cement block, and they do this like 100 times. And then they go and they hook up again and measure the insertion loss and return loss. They check for any kind of mechanical damage and whatnot. And they do this to 30 connectors. So they get that statistical appreciation for it. And so there's all that mechanical testing that happens. Now, when we talk about environmental testing, they use these environmental chambers and they have the connectors all in there. They do a thermal test and they thermal cycle it, and they do humidity and all kinds of torturing of the connectors, and then they dry them out, and then they do a post-condensation test. And all this happens over top of that 21 day, that cycle test of that I was showing you, and really it really tortures those connectors, and they're always monitoring insertion loss and return loss, making sure that they didn't crack, they didn't deform, this kind of thing, and to make sure that you are getting a quality product. Then there's dust testing, adhesive testing, salt spray, corrosion testing, and then they put it in, they submerge it in groundwater, they freeze it and they thaw it, and they're constantly measuring the insertion loss and return loss when they do this. And so the bottom line is, after the connectors have gone through all this very rigorous testing, it really is simulating what's happening out in the real world. In my lab, you know, it's very, very controlled environment, but in the real world, like outside right now, it's about -10 Celsius. Those connectors and whatnot, they have to be able to survive. So this leads us to a declaration of conformity. And this here is listing the GR326 and GR1081, which is a subset of it. And the IEC specifications are stating how the insertion loss and the return loss are measured. And it follows those very precise measurement standards. And then we have Cy Johnson, our VP of Engineering, who signed off on it. Okay, so you know that you have a quality connector. So that's basically the mechanical connector. And a lot of testing goes into it, and it's very, very good for that last mile kind of connection. Another method is a splice-on connector. Now, a splice-on connector, you know, there's a lot of them out there nowadays and whatnot, but we feel that we have a very, very good product here because it's truly universal. This splice-on connector can be used in any manufacturer's fusion splicer because there are no special fixtures, there's no special adapters, there's no training needed if you know how to already fusion splice. And it's very, very simple to use because there's only 3 parts. You have the splice protector, you have the boot, and you have the actual connector with the pigtail. And it's really a pigtail that's about 5 inches long. So you're able to load fiber to fiber inside the fusion splicer. You don't have to have those special adapters to hold the shell of the connector. Because if you have a tempo splicer, the Sumitomo splice-on connectors won't fit in it. The Fitel splice-on connectors won't fit in the Sumitomo. The Fujikura won't fit in the Sumitomo. But everybody, we can place these splice-on connectors into anyone's fusion splicer because it's really like just splicing fiber to fiber. There's no special adapters, no special training. Very, very simple to install, and it makes for a very, very low loss, low reflectivity connection. And so when you think about a fusion splice, there's no way that you can have an air to glass interface. And an air to glass interface is what causes the trouble. When you have light propagating down a fiber and it hits an air interface, just open fiber, 4% of that light could reflect back, which causes a huge reflection. That's a huge, huge reflection. And so, this is not the case when you use a splice-on connector. There's no opportunity for that unless someone cuts the fiber. But when you use this splice-on connector, there is no glass-to-air interface whatsoever. So the splice-on connector specifications, you can use it on 250 micron, 900 micron cables. We have them in SC and LC variations. Here you can see an LC APC connector with the boot placed onto it. Of course, there's UPC versions also, and they're available. SC, APC, and UPC are available for single mode, and then multi-mode. Of course, that's just a PC type finish, a flat finish, and that's OM1, OM3, and OM4. The typical lot, the maximum allowed loss of a connector is about 0.3 dB. But typically, you're looking at 0.15, 0.1 dB, something along those lines. And so it's identical to any other connector that's out there in the market. And of course, the return loss, the APCs are better than minus 65 dB. That is like way down on the dirt. Multi-mode, 35 dB down, pretty darn typical, okay? And the end face geometry of these connectors, same factory, of course, is GR326 compliant. So you have that assurance that these connectors are going to be a high quality connector and not cause trouble in the future, not have re-rolls of trucks and whatnot. So you can see that the boot looks a little bit bigger than you're used to. And really, it allows you to have the ability to place that splice protector inside of it. Remember, we can do 3 splicing attempts. The 3 splicing attempts happen like if you were to want to reuse a connector because you made a bad splice or bad cleave or something like that, you still have the opportunity to do 3 splices, 3 splice attempts on it. The boot itself is about 5 inches long, and it prevents you from making a macro bend. If you make a macro bend at the connector, the connection point, you've got a really big problem there because there's no way you should be able to bend that boot to cause a macro bend, to violate the minimum bend radius of the fiber, which is about 15 millimeters. But there's still lots of room. You can put it inside of a pretty darn small cabinet. There's not a lot of interference there at all. I've never seen anyone have an issue with that. Okay, so that boot, people think, oh, it's going to get in the way. Not the case. It's very, very supple, and you can bend it quite easily. It fits into and routes nicely in channels and whatnot. So no issues there. So to do the assembly, first things first is to put that boot on and the splice protector. If you don't, and when you're going to, invariably you're going to determine that you didn't do it when you made the splice, you're going to have to cut that connector, that splice out, and redo it again. But remember, you have 3 opportunities here. And so normally, if you forgot to put a part on when you're doing a conventional splice-on connector, you're going to throw that connector out. There goes 10, 15 bucks, right? That's gone. In this case, that's not going to happen. And our splice-on connectors are not $10, $15 or less than that, but distributors can help you out with that. But you're not wasting connectors. But anyways, you put the boot on and the splice protector, and you cleave the fibers and all that business. And here you can see the 915FS fusion splicer that we sell with the 2 fibers loaded in. And the splice-on connectors on the right-hand side and the field fiber on the left. So you complete the fusion splice, and here's the fusion splice. You move the splice protector onto the fusion splice, shrink it up in the heater, and then you put the splice, the boot onto it. Okay, you install the string relief boot, and you're finished. That's it. Okay, so you have a very, very simple connection, and you know that you're not going to have any glass to air interface issues. It's just like solid strand of fiber. Okay, no problems there whatsoever. So in summary, we have 2 different kinds of connections that could be used at fiber to the home, the last mile. And the first one that we talked about was mechanical connectors. It's very fast, and no fusion splicer is required, so it's very economical. It gets you out there and terminating very, very quickly, and at a very low cost. And so it gets your feet wet at least, and gets you out there and gets you productive. Splice-on connectors are the ultimate in fiber to home installations, or any installation really, and in the networks, because there's no glass to air interface, and it's just a solid piece of fiber, and you have the lowest possible return loss, and you don't have to worry about excessive losses because of fibers opening up and whatnot. And the splice-on connectors that we sell here at Temple Communications, they can be used in anybody's fusion splicer. And no special adapters, no special fixtures, no special training. If you know how to splice already, you'll be up and running immediately. And best of all, GR326 compliance on the mechanical connectors. We have that totally locked up. You can get the declaration of conformity, and of course with the splice-on connector, everything has been looked after. The fiber interface geometries, everything is GR326 compliant, and it gives you the assurances that you're installing a quality product into your network, because you don't want to be going back and fixing things unnecessarily, doing truck rolls again, and trying to get things running again when you have a very irate customer. So that's what I had for today, and Ashley, I'll pass it on to you. Back to you.
Great. So we are open for questions. If anyone has any questions, please put them in the chat. I have a couple here, Keith. One about the splice-on connectors. Do the splice-on connectors use loose tube fiber?
Splice-on connectors that we sell here are type buffer, so you don't have to worry about pistoning. If you had loose tube fiber, the fiber inside could move, and it makes it difficult for the fusion splicer to hold on to the fiber. We do have a solution for loose tube fiber. It's loose tube adapters that hold the fibers in place if you are using loose tube, like in fan-out situations and whatnot. But our splice-on connectors use tight buffer fiber, so you will not run into the pistoning issues and stuff like that.
Great, thank you. People are just saying thank you, thank you. Here's a question: what type of glass is used in the SoC? 657A or B?
A.
657A.
657A.
Another one. What is the proof test?
The proof test, when you're doing fusion splicing, for instance, is when you can. Everyone's seen this if you've done fusion splicing. It's when the fusion splicer has spliced the fibers and then it pulls it apart. And usually, like in our fusion splicers, it's around 2 newtons of force. Now, the proof test on the mechanical connectors, what they're talking about there is when the lab was doing it, they were hanging weight onto the end of the fiber to see if the fiber would detach from the connector. Okay, So they're actually loading it and causing like basically hanging a weight off it to make sure it doesn't break apart. It's kind of like in the fusion splicer, 2 newtons of force pulls the 2 fibers apart and making sure that the fiber wasn't cracked and it doesn't break at some point in time.
Awesome, thank you for that. Another question, I believe they're asking how much longer do connectors last? I'm not sure if that's compared to, I mean, you probably know better than me, Keith, but how much longer?
Okay, the connector between a mechanical or a splice-on connector is no difference. But for instance, the mechanical connector has a 20-year lifetime expectancy. Okay, it's guaranteed for 20 years.
Awesome, thank you. Any other questions, anyone? They asked about if we are going to send a recording. Yes, this webinar will be, the recording will be sent out to everyone who attended. Also, it's on our website. You can find all of our past webinars on our website. I'll put the link in this chat as well. And you can always reach out to Keith if you have any further questions. He's open to receiving emails from you. He's happy to help. So I put that in the chat as well. And you can see our sales support information here on the screen. So if there's not any further questions, thank you again so much for joining us today. We really appreciate it. And we hope you join us again for another webinar in the future.
Okay.
Thank you, Keith. Thanks, everyone.
Thanks, everyone. Okay, thank you. Bye-bye.
Bye.